All right. So very, very welcome to this launch of the Edge Annotations Challenge. We're really, really happy to have you here today, and we're really happy to announce that the challenge is now launched. My name is Ebba Josefsson Lindqvist. I'm a project manager at AI Sweden. And AI Sweden is an organization that is trying to accelerate the use of applied AI in Sweden. And this whole challenge is part of one of the projects that we run at AI Sweden called the Road Data Lab. And you will learn more about that project a bit later in this session. But today we're focusing on the challenge. And as you might have seen already, the challenge that we are setting up is automatic annotations. And we will deep dive into what this means in just a few minutes. But first, just so you know, this webinar is being recorded. You can also use the Q&A functions here in the webinar setting to post your questions. And please do if you have any questions. And we will have a Q&A at the end of the webinar. And of course, I want to say thank you to everybody who is participating and helping out with this challenge. And of course, Sensex is one of the main organizers and also host of the challenge. And then we have also RISE, Chalmers Industriteknik, Universes, Lund University, AI Sweden, and we also collaborate together with CGIT and Mobility X Labs. And as I mentioned, this is part of the Road Data Lab project, and we're really, really happy to kind of end the project that is ending just in the beginning of next year with this kind of a bang event to do the challenge and make the most out of what has come through the project. And the challenge is launched as of today, and you can find all the information about the challenge on our recently published website. So you can find that link in the chat here. You can also find it on AI Sweden's website. And please spread the word. We want the best teams to compete in this challenge. It's a global challenge, so please make sure to spread the word if you find anybody that you think should participate in this challenge. And of course, it's interesting to know when this challenge is kind of taking place. So it's open now for applications until January 10th next year. Then we'll have a bit of an assessment period, and we will announce the selected teams on 18th of January. And the kickoff of the actual challenge will be January 21st, and it will run until February 3rd. And then we'll have a closing event on the 10th of February. So that's the timeline, and I will show you a slide on that a bit later, and you can also, of course, find it on our website. So that's it for the formal introductions of the event, and now we have a greeting from the CEO of Sensex, Ödjad Andersson.
Hi, everybody, and welcome to the Edge Annotation Hackathon. Super excited to have all of you here. My name is Ödjad Andersson, and I represent Sensex. We're a company making the next generation systems for cars to become autonomous, and also improving the advanced driver support in the cars. The reason we do this is because we want to make roads safer. We talk about moving towards zero collision faster. And how does this fit into that vision? Well, the next generation of cars will have improved eyes and an improved brain. That means we will put sensing in the cars that's significantly better than today, and some real serious compute power as the brain of the car. We do this in order to enable autonomous drive. But the good news is we can also use all that tech to enable improving how you support the driver in all the miles that people are driving themselves, basically making every single mile on the road safer. And as we do this and create this new type of system, we will also have the entire fleet of cars driving around with these capabilities. And what we want to do is to use them to collect data, and we want to use that compute power to actually process that data. And an autonomous drive system relies on machine learning to train our algorithms, and basically understanding what the sensors are seeing and translating that into knowledge. In order to do that, we need to annotate to teach the system what it's actually seeing. And today, that's a rather manual process. And that's a bit of a problem if we want to do this in the fleet. We want to use the computers and the sensors out in every single car, basically making them an edge device. But then we can't have a manual process in the car. So we are looking forward to your great ideas in finding ways to automate the annotation part, which is more or less the only manual part we have in the process right now. So good luck to all of you, and I really look forward to the result of your hackathon.
Great. So with that, we would like to welcome two of the instigators of this challenge. Please, Benny and Mina, can you come here? Also try to get that nicer screen. I think we'll have to live with that background for a bit.
Lost the connection with audio.
So, Benny, we heard Ödjad here say that there are a lot of issues with and fatalities. You have collisions on the roads. Can you give us a little bit more information about what Sensex is aiming for with this?
Yes, so relating to what Ödjad was talking about, we have annually around 1.3 million fatal accidents related to on the road conditions, but we also have around 20 to 50 million injuries as well. And as I had mentioned, we have a vision that we want to move towards zero faster and accelerate that process. So by doing it as fast as possible, we can save more lives and reduce injuries. And also what is very important in the message that he convened is that it's related to collisions. So it's not only about protecting the occupants of the car, it's also about protecting what we call the vulnerable road users, like pedestrians, bicyclists, motorcyclists, and so on. And it's most of these accidents towards vulnerable road users are because of human behavior. So to solve that challenge, we need to improve the performance of what we call our advanced driver assistance systems, and also further on full autonomous drive.
Great, thanks. Just for Pierre, can I ask you to help me just change the backdrop? I can't find it, and then we'll continue.
Yep.
Sorry, everyone. That looks great. Thank you. I think we could leave it for now. Yeah, let's do that. All right, so thanks, Benny. So there are really things we can do to make the situation better. But then you mentioned the ADAS and the autonomous drive systems. They need data.
Yes.
Right? What are the challenges here?
Yeah, so this is one of the large challenges that if we really want to move towards zero, these systems has to work in all different kind of conditions. So we're talking about, for example, different environmental conditions, like the time of day you have, for example, it has to work now when it's dark outside, during day, it might be sunset when you have the sun into your cameras, for example, that's a challenge. We have different weather conditions that we need also to handle. It might snow, it might rain, you might have fog, seasonal changes, trees change over seasons, you might have leaves on the road. Other conditions like different parts of the world have different types of vehicles. We collect a lot of data here in Europe. We don't have many tuk-tuks on the road here, for example, but in different parts of the world, they are very common. Animals on the road, there is a lot of accidents with animals, but when we collect data with our development vehicles, we don't see much animals. It's quite rare that a single vehicle actually sees animal on the roads. Also, any kind of what we call general objects, it might be trash bags, timber, or anything that might fall off from a truck, for example, and might blow in from the side of the road. We have to be able to handle that. And then making it even more complicated, we need to be able to handle all of these different combinations. So it might be something generic on the road, in the fog, with low sun, for example, making everything much more difficult.
All right, so this actually does sound quite complex. It doesn't sound like an easy task just to do that. And Ödjad also mentioned that there could be a way to manage some of these questions by using the customer fleet. Can you elaborate a little bit on what she was touching on?
So with the customer fleet here, we mean the vehicle containing our software, and also these vehicles will have kind of a required level of hardware connected to that. And the amount of vehicles that will have our product in the longer run compared to what we call our development fleet, the vehicles in that fleet, it will be many order of magnitudes more vehicles. So that means that we can, all of these different conditions I mentioned previously, we will be able to find all of these rare cases significantly faster than if we would try to do it with a much smaller fleet of development vehicles. This will give us the possibility to significantly reduce the time it takes for us to improve the performance of our software. It will also mean that we can increase what we call the operational design domain faster, that especially our the AD software will from the beginning work on very specific condition, and then it can expand quite rapidly. It's also better for the environment. We have a development fleet right now with vehicles only driving around collecting data. They have no other purpose than doing that. But if we instead can use the customer vehicles where they are driving around transporting people or goods, perhaps even, and we can use that to identify and collect this data that we want to learn from, we kind of piggyback on that, and we can utilize these vehicles for more than only collecting data. And also it's more cost effective because of the reasons that I just mentioned.
So it has quite a few benefits if you could actually use the customer fleet, and the cost efficiency, good for the environment because you'll get less cars on the streets.
Yeah.
And also maybe some other potential issues that looking into actually using the customer fleet, I guess it's not an easy road to go either. I guess it comes with a few challenges.
Exactly.
Going in that direction, it's nice to have the cars that you can control yourself.
Yes. So, I mean, the simplest of solutions would, of course, be to identify the data we want, send it to the server, and then process it. But we need to also, and we want to respect privacy legislations like GDPR. So that means that we have to process the data and improve our software within the vehicle that has generated the data. And so we need to find these methods how to actually do that, and that's a big challenge. And it's beyond also just updating and improving the software. We need also to check that everything we changes is safe. So we would never make a change to our software within the vehicle without extensively testing that it's safe to then deploy within those vehicles. So we need to create methods how to send the model results back to the cloud to ensure safety. And so what we see is that one potential way, at least, to approach the challenge of doing the software updates at the edge in the vehicles is to use what we call automatic annotations.
Mm-hmm. Yeah. And before we dig deeper into that, what role do you have at Sensex? Why is it important to you?
So I am the head of emerging technologies, so it's my kind of responsibility to explore new technologies, and this is very both challenging and fun area to work with.
So you come up with the best challenge actually that you can.
I hope so.
Yeah.
We will know more in a few months.
Yeah, exactly. And then also Mina, we have you.
Yeah.
What's your role at Sensex?
Yeah, my name is Mina Alibegi, and I think most of you know me, but yeah, I'm an AI researcher working with technology and collaboration at Sensex. So basically we are working in this problem together, so in the team.
That's great. And Ben, we mentioned before that this was also part of the Road Data Lab project, and this challenge has kind of come up from that project. And can you just say 2 words about why Sensex is part of the Road Data Lab?
So it's being able to create a dynamic and positive ecosystem where people can have access to good road data is something that is very important to us. So we are very dependent on the research community when it comes to, for example, what kinds of deep neural network models that we're using. And we also have quite a lot of our own PhD students that need to work with data, publish on data to improve the product we have. And so it's a great value to us to create an ecosystem where they can use Sensex data for their research and publications, which makes it much easier for us to use that in our own development. It's also a value for us to have other researchers actually doing research on Sensex data, because then the threshold of using those results in our own development becomes lower and easier.
Great.
Yeah. Mm-hmm. And the Road Data Lab is a project to try to build upon a community and tools to enable this.
Great, thank you so much. And we'll meet some of the other participants in the Road Data Lab in just a short bit. But so Mina, I'm back to you.
Yeah.
So we do have this challenge that Benny was talking about. Exactly. And then, so what are the requirements for enabling edge learning in these customer vehicles?
Yeah.
Or for autonomous driving?
Yeah, that's a good question. So just a recap, as you already know, we have many tasks for autonomous driving, and some of them can basically be trained with the data itself, but some of them need some form of supervision, like annotations, to be trained, basically. So, but the challenge, as was mentioned by Oddgeir, the challenge is that we don't have this. Actually, like annotation usually are done with human annotators. But the challenge is that when we are doing learning at the edge, then we don't have access to those skilled human annotators. And we basically, as mentioned by Benny, then in most of the cases, we have some issues with transferring the data out of the car, like because of the privacy or data regulation and so on. So then here we need new methods to basically generate annotations automatically to enable edge learning. And then it can help us to accelerate basically the development of autonomous vehicles and also improve the future of mobility.
So, for example, Benny was mentioning the privacy, for example.
Exactly.
This would be able to enhance privacy.
Yeah, because then the data doesn't need to leave where it's actually born. So there are no privacy issues in that regard.
Sounds like magic in a way. Having a background as a lawyer, I think everything like this kind of technology sounds like music to my ears. Yeah. So if we come back to the challenge that we are putting up today, what is this challenge about?
Yeah. So in this challenge, as I mentioned, the history. So in this challenge, we want to generate edge annotations for one of the common perception tasks for autonomous driving, which is object detection, basically. So we want to train single frame 3D object detection by creating automatic annotation. So we can do the learning at the edge in this challenge.
Yeah. All right. It sounds kind of challenging, I must say. And so what are the type of conditions that you would like to simulate here so they know a little bit more in what you're looking for?
So basically, because the reality is that basically we do this automatic annotation generation when, for instance, let's assume that the car is driving for a while and it has a limited amount of storage. So during the drive, it stores a little bit of data. And then when the car is parked, then we want to run this automatic annotation generation module. And then when we created the annotation, then we can basically do the edge learning. So what we want to also ease here is that then you don't need to worry about, for instance, the latency for the real-time system, because basically the edge learning is supposed to happen when the car is plugged in and also parked. So
it's standing still, it has energy.
Yeah, exactly.
Okay.
Yeah, exactly.
And that makes it a little bit easier, or?
Yeah,
quite
hopefully.
still.
Yeah, but still we need solutions that can work in the car, because the automatic annotation generation is supposed to be run in the car. So we cannot come up with ideas that are very highly computationally heavy. So
all right. And what about the information here? Is it passed?
Yeah, and also the good thing then will be that people can assume that they have access to the past and the future information. So if they can benefit from using the information from past and future, then that's possible, because then the car is parked for that purpose. Yeah,
sounds good. And then, of course, very interesting. What is the data that Sensex is making available here?
Yeah, so for this challenge, we have actually are publishing a brand new data set by Sensex, and we are going to use that data set during the challenge. It is a sequential multimodal data set with very comprehensive annotations for different tasks. And the point is that the data set is recorded during day and night under different traffic and weather conditions.
So similar to what Benny was mentioning, the challenges that you're facing.
So hopefully it have enough challenges for you to solve, basically. And it's a good sample of the real world data set, but of course, still not that big.
But it's brand new and not shown to the community before. So this is really a contribution.
Yes, they will get early access to that data set by participating in the challenge.
Exactly, that's great. So that's kind of what the collaboration here is about, that the AI Sweden will provide infrastructure and kind of host the challenge. Sensex is providing the challenge and this unique data set. Yeah. So great. Thank you so much.
Thank you.
I have one more question just before I let you guys go. Why are you sharing this data set? You could keep it to yourselves. You've put in a lot of effort and time and money into creating it.
So I touched upon a few of the reasons before. I will reiterate. So one is, of course, our own researchers, that we want them to be able to publish on Sensex data, because that makes the results from the research easier for us to use. I also mentioned that we want other researchers to publish on our data, because that also makes the results easier for us to use. As I said, we are following the academic results from especially AI quite thoroughly. And what we've seen is, especially over the last year, that when it comes to these pure research data sets, that a lot of organizations, including our own, are hesitant to actually even having them within our own environment, because we don't want to risk polluting our development with research-only data. And that's why we are releasing this data set for also commercial use, to make sure that as many organizations as possible actually dare to download the data set and do research on it. this has really changed for us over the last year, because if you would have asked us a year ago, we would definitely had released the data set for research only, but then we realized that there is a lot of data sets we cannot use on our own, so we had to reconsider with what we also release. And this change of mentality is also coming to the hackathon. So the results from the hackathon will actually be owned by the competing teams. And the reason for that is to have the best possible teams competing. And that gives us then a really good way of getting like a first exploration of this area that will help us in further development.
I think that's a really good encouragement to anybody out there who has good data, that you can actually make a lot out of it, or you can make more out of it if you dare to share it. So I thank you so much. It's a great example for us at AI Sweden. We really appreciate it.
Learn a lot doing that.
Right, exactly. So thanks so much. I'll ask you guys to come back again at the end of the session for the Q&A. But thank you for now.
Sure, thank you.
Now we'll actually have another greeting from, let me just prep here. Dennis Nobelius, who is now the COO of Polestar, is sending a greeting to everybody who wants to take on this challenge. So let me just start this video.
At Polestar, and the reason why I'm here today to pitch this hackathon for you, I would assume, is that I was part of making AI.se happen. And I also started Mobility X Lab inside Zenuity Sensex premises. So I think that goes without saying. I'm really fond of this when you meet the small teams with the bigger needs from the society and make that a successful work together. So what I would like to do is that I would like to say that Polestar, first of all, is a customer of Sensex. So the software coming for unsupervised highway driving will land in a Polestar 3, not only Volvo cars, but also Polestar cars. And of course, that is very important for us, a very strong feature moving forward, and something to bring or to increase the road safety quite substantially. So we believe strongly in that, and we look forward to making this happen together. When it comes to then Edge Lab and the annotation piece, etc., I think we've done a big job in getting the AI, the vision team, everything in place. And this actually started on a fun note when we had a big contract together with HPE, Hewlett Packard Enterprise, and happened to have then the CEO in our premises, and we asked him to give us like 5 minutes at the end, just to pitch a new idea from Mats and the team. And that idea was very much what became then the Edge Lab. So we look forward to this, to bring this to the next stage. For me, this is the best of two worlds, what you will be doing today and the coming days. And that is when you have AI to meet the small concept of a hackathon. Because then you have the innovation, directly applied in small team setting with machine learning as a base, which then can benefit in the automotive society and the automotive world. So let's make innovation happen. And my encouragement to you would be to join into small cross-functional teams, share your ideas, be bold, and let's go. Thank you for joining.
So Thomas, Johanna, and Sid, if we start with Thomas, what organization are you from?
Right, so I'm a senior researcher at RISE, Research Institutes of Sweden.
Perfect, thank you so much. And Johanna, please.
Hello, Johanna. I work at Universes and I'm a product manager there.
And Sid.
Hi, I'm Sid. I'm a data scientist at Foundation Chalmers University Technique, and we deal with public funded projects mostly, similar to RISE actually.
All right, great. Thanks so much. And you're all project partners of the Road Data Lab. And I should also mention that Lund University is another project partner of the Road Data Lab. But Thomas, why was this project started in the first place?
Right. So with machine learning, obviously data becomes one of the central resources that is needed to train models. And then obviously you need to figure out where to get the data from and how you work with the data. And we know from working with open source that if you want to share data, want to share assets more in an open innovation manner, this will impact your business models. This will impact the legal aspects, liability, licenses, and so on. So it's actually has far-reaching impacts if you want to share assets more than kind of the technical part of it, actually using the assets in the technical part. So the RODO project, the RODO Data Lab project, wants to create this data ecosystem where it's easy to share data and where there are support for doing that in licenses and so on. And in this project, we kind of taking the first baby steps, and it's really good to hear from Sensex and Benny saying that they have already started this journey and how they want to work with open data in this project. And I think we want to learn from those experiences to see how can we spread this further on to the kind of the innovation ecosystems in Sweden and in the world, obviously.
Great, thank you so much. And if I go to Johanna then, why do you think it's important to create this kind of community? And maybe you can mention a few words about Universes and what you do.
Absolutely. Yes, so Universes is a smaller startup, and we have our expertise in computer vision and machine learning. And we're developing a product connected to smart cities where we are using that knowledge to collect data in the cities and giving the cities insights about what's happening around, for example, roadworks or road conditions or traffic signs. And I think for us, there's a great value of collaborating. I mean, we can create new value using just the existing data that's already there. We can use existing annotations for new applications, or even enhancing quality of detections and enabling new revenue streams in that way.
Great, thanks so much. And Sid, your organization has a bit of a different background, but why do you think it's important with a community for road data?
I think it's really important in terms of, let's say, long-term planning of roads and road infrastructure, and also city planning. And we are actually a part of this center called Digital Twin City Center. So actually, parallel work is going on to collect data of the cities, which is pretty much similar, and that's one part. And also about how can we deal with, let's say, renovation, and also how do we make sure that we have low carbon footprint and be sustainable in improving the infrastructure, and also have a zero vision. So that's these are some aspects that I think are really interesting.
So that sounds like it aligns you and Sensex in many ways, right? But so the main reason for your organization to be part of the RODL project, what is that?
I would say it's the first thing. I think we were part of forming the consortium. That was initial idea, and then actually to bring in ideas from different domains and areas. And also the most important part I work with in the project is to let's say, how do we make or create value out of the data. So we come up with so many ideas, but then not all ideas are really, I mean, they don't have, okay, they might be fancy or fun to implement, but it's are they actually creating value? And that's the most important question I think we need to answer on how the data should be used. And this is what we are working towards in, let's say, trying to merge different kinds of data sets and also, let's say, benchmark a few data sets and compare what's happening around, and maybe even augment few data sets with, let's say, metadata, trying to collect more metrics out of it. So, yeah, this is an overview of what I think we're trying to do here. Yeah.
Great. Yeah, there seems to be a lot of reasons to kind of join and listen in on what's happened on the project. And if I go to you, Johanna, what have you learned so far from this project, collaborating? It's actually been going on for 2 years now.
Yes, so I think mostly we've been learning that just the potential of speaking to each other and taking the experiences from others in maybe other domains, but still working with the same areas. And yeah, also the challenges that is connected to data and licensing, and also privacy that we've spoken of before here. And yes, I think there will be a lot to read from the Rodel project that will be interesting for many people, I think.
Great, thank you so much. And back to you, Thomas, you've been the project leader of this project. Can you mention something that you've learned from the project, and also what are you looking forward to mostly with this challenge?
Yeah, it's quite interesting to compare open data and open data ecosystems with open source and how you work with open source, which there are obviously similarities, but also a lot of differences in terms of the asset, which is data here instead of source code. And I think that has really been a long journey for us to understand, specifically the licensing part and the kind of liabilities that are entailed with that. And that was really one of the big challenges. I think that what's interesting with this challenge is really to see if we try to do open innovation on data, what can be the potential effects of that, what can we gain from that. And I think those kind of experiences and learnings from that is really what we can use to promote sharing of data going forward and understanding what is the value of doing that.
Great, thank you. And Johanna and Sid, just a few short words about what you're looking forward to in the challenge.
Okay, I'll start. So I'm hoping to see a lot of motivated and innovative teams that will, there'll be a lot of action and a lot of good results.
Great, thanks. And Sid?
Yeah, I'm really looking forward to see what new ideas are out there, because we've been looking at different possibilities and we tried few, but then it's to actually see new solutions. It's really interesting.
Great, thanks. And the participants that selected teams will also meet you guys throughout the hackathon as kind of mentors. You will also be part of the screening process. And then if you want to find out more about the Road Data Lab, you can find more information on AI Sweden's website, for example, and also in connection to the challenge page. And the challenge page, of course, you find here in the chat. So thank you so much, Johanna, Sid, and Thomas. We really look forward to working with you on the challenge and what teams that will apply. Thank you so much. And that takes us to our next speaker. And we have the pleasure of having Brian Reimer from MIT with us today. Hi, Brian.
Greetings, Ebba. How are you doing today?
I'm doing very good, thank you. So happy to have you here.
Thank you.
So we've asked you to give an inspirational speak to give the attendees today, and they hopefully are our competitors soon for the challenge, to understand why this is important and how it's aligned with your research and why we can actually save some lives if we manage to tackle these challenges.
The complexities of traffic safety and providing the driver with more convenient, comfortable, and environmentally efficient transport is a challenge that, hopefully driving automation systems, whether they are, human-assisted, partial automation systems, collaborative, or really full automated technologies, have the potential to really mitigate a lot of the harm and that is being seen on the world's roads today. But as we look at automation and AI in particular, the AI is really only as good as the data you're building the models on. We've long known in the pursuit of advanced artificial intelligence solutions that garbage into a model is garbage out, no mystery. Well, when we are looking at annotating, millions of miles of roadway data, it's really easy to overlook the complexities of annotation. And we see that by and large in many of the organizations out there today, where we're still looking at manual annotation as an approach to labeling, tens of thousands or millions or billions of images, and focusing on the algorithmic developments to how to drive cars more efficiently and safer and avoiding complex scenes. But when we look at the use of AI in particular, this challenge, as well as some work that we've done at MIT over the years, has looked much more of how do we turn that AI around and how do we really begin to use the AI to label data. And automatic annotation, and perhaps even more importantly, semi-automated annotation, where we are using the automation where we can and bringing in a little human expertise, is probably the most important advance in AI and data sciences out there today. Because if we want to be successful in automating or improving solutions, it's all about finding the edge cases that we don't understand today, identifying them, finding them in real world data, finding lots of illustrations of those cases. These are the things that happen once every million miles that we can't look for by hand anymore. So when we look to automatic annotation and automating annotation and semi-automated annotation, it's really, where do we use the AI to find stronger data sets that we can actually build models on? And I, for one, believe that we are overly focused on building algorithms for the sake of algorithms and under-focused on ensuring that we are leveraging the data we have most effectively. And I think investments in improving the efficiency, effectiveness of annotation are really critical today. So this challenge is quite important. And I think advancing AI science is a broad whole. I think we're going to do more with data and in refining the oil that builds our models than we are going to actually improving the modeling approach themselves. But when we think about automating annotation, I'd like everybody to think about this for a second, is that, look, machines are good at some things. Machines are really good at making black and white decisions. And quite frankly, even with the best of deep learning, and getting better at separating cats and dogs when they do look alike. But many times it does come back to the art of human expertise. And perhaps the most important thing about automating annotation approaches is automating the simplicity. If we can automate the annotation of 99.999% of the data, and then leverage our human expertise to improve the annotations of the complexities that are beyond the automation today, we can begin to enhance the effectiveness over the long haul. When we do that, one thing that we want to begin to look at is the confidence measures that different automation approaches provide to us. Leveraging the automation where it is providing a confident solution, and then blending in humans who are really good at judging gray areas when the automation is not so good. So this also means that when we think about automation, it becomes about the AI we build, but it also becomes how do we efficiently bring sparse pieces of information back to human annotators and expertise more efficiently, and improving the whole product pipeline structure that's required here to efficiently move and label copious amounts of information. So when we look forward, as I mentioned, it's really probably less about the art of developing an automation algorithm to drive a car. And it's more about how do we weed through the copious amounts of data to learn about the edge. And that's both what we're talking about here within the conversation today about what we can do in processing at the edge, because we can't move all this data anymore, and how we can begin to think about annotation both in the data warehouses, as well as how do we leverage that in real time. And the more we can push out annotation and push things out to the edge and begin to leverage automation in ways beyond what we have been traditionally looking, providing an end product in the back end applications, the more successful I think we're going to be at mitigating the harm of 1.3 million global fatalities a year, and bringing more seamless, comfortable, convenient, and environmentally friendly mobility to the masses. And with that, Ebba, I'm happy to take any questions.
Yeah, thank you very much, Brian. And if you can stay on for a little bit, we might have some questions. Maybe you can also type in the answers, but thank you so much for putting this in your perspective. And maybe you can say just one word about what you're focusing mostly on in your research right now.
Sure. So my efforts that I lead at MIT in particular are collecting naturalistic driving data for understanding how humans are interacting with some of the more advanced production level automation systems that exist on US roads. So we have collected well over 1 million miles of naturalistic data in an academic setting where we are investing probably pretty close to a third of our budget in annotation. And any of the efficiencies that we can use to improve the quality of annotation improves the modeling we're doing, and perhaps moves us closer to being able to open source more reliable data sets over the long haul. And I think that, some of the words said earlier, open sourcing data is very, very difficult because, what do you trust and how do you impart biases in data through annotations is something very hard to transfer technically through the open source process. I mean, just drawing pedestrian bounding boxes around pedestrians sounds simple in one sense, but every time you label pedestrians, you are making decisions about what are you including, what are you excluding, what is the framing effects, which data is actually reliable enough for you to build your algorithm on, and what is not. And something simple as driving in the snow or the rain, is going to be very influenced by these labeling decisions that we're making. I'm also working with some of the colleagues at AI Sweden on the foundations of the Edge Lab, helping to kick that effort off and support the development of a new edge learning consortia and advancing the state of applied AI research within Sweden.
That's great, Brian. Thank you so much. And also potentially, depending on what comes out of this challenge, the Edge Lab can be one place where some of the best solutions here can be tested further to actually take it to the edge.
Exactly.
So thank you so much for tuning in. Really great to have you. And we hope that maybe some team can come from MIT. Let's see. I hope you're up for the challenge. Thank you so much, Brian.
Thank you.
All right, and we've started to talk about the infrastructure a bit here, and our next guest is Simon Jonic from CGIT. Welcome up, Simon.
Thank you.
So we've mentioned the Edge Lab. That is something that happens at AI Sweden here in the Gothenburg office. But we also have other infrastructure, and we are providing part of that for this hackathon, namely our DGX A100.
Correct, yes.
But before we dig into that, so CGIT and your role at CGIT.
Absolutely.
What is that?
Yes. So I'm Simon, as you said. I'm one of the leaders of our development team within CGIT. Work with AI infrastructure and long-time collaborator with you at AI Sweden. So CGIT is from the base a infrastructure company. And we're now for a couple of years been working heavily with AI infrastructure for customers around Sweden. And then, of course, a big partner at AI Sweden, supplying infrastructure and then expertise to set it up.
Great. And what type of infrastructures do you help clients with?
So any really deep learning oriented infrastructure. Of course, that's mainly been with the GPU accelerated hardware. So mainly NVIDIA boxes, accelerated with fast enough storage to serve the GPUs. And then, of course, quite beefy interconnect to connect all the parts together. So that's the kind of recipe we go by, and have done successful deployment of all sorts of customer sites. Based on that infrastructure, we have that also in our own data center. So we have that for POCs and for projects, and that's also what we're going to use for this kind of collaborations. Great.
So the infrastructure that AI Sweden has, which you help us with, it's a DGX A100. But can you tell us a little bit more about setup?
Absolutely. So yeah, it's as you said, a DGX A100 in the bottom. So it's 8 of the A100 GPUs, 40 gig version, that are then interconnected with pure storage FlashBlade architecture. So we have access to fast disk to be able to leverage the GPUs efficiently. That's all interconnected with Arista switches with deep buffers, which is very important to get the speed you need to make that shuffle the data around fast enough. We then, of course, provide some resources on top of this to be able to support the infrastructure based on different use case needs and stuff like this. So we help with user management and all the collaborations we need to set that up to efficiently use it, both in project form and for separate users.
Great. And then so you said 8 GPUs. So basically our plan is for each team, that's why we set the number to 8, to be able to have 1 GPU each.
Yes.
And this machine, how new is it, or like what's if you compare it to something else out there, is it great, good, or?
Yeah, so the predecessor to this was the DGX 1, basically. So that was released about 3 or 4 years ago, and this is about 2.5 to 3 times general performance increase, which is an obscure number, but it means for quite a few of our customers, there's been over 100x increase in the performance utilization based on cloud consumption needs, based on Google Cloud GPUs and stuff like this. Meaning you can iterate so much faster, get results back faster, so you can move on with your training.
Cozy and dark.
Dark time.
Yeah. This is Sweden in the winter time. We're working on the light settings. We have some interesting technical issues here today. Thank you, Simon.
Yeah.
So I assume that these kind of machines are not everywhere.
No, exactly. No, so these are high performance data center machines. They shuffle a lot of both air and power through them to be able to support this operation. So they're quite dedicated machines, need to be handled with care and understanding of what the machines are. But the user experience is probably going to be quite native for most users. It's the hope and goal that you're going to feel at home.
That sounds great. And you will be, of course, supporting during the hackathon, so kind of doing a bit of technical support and also talking a little bit more about the infrastructure at the time. But so why do you think it's important to do these kind of collaborations from your end, from CGIT?
Well, of course, to strengthen our relationship with the partners, to have a joint understanding and to further the access and utilization of AI within Sweden. That's why we're a partner for AI Sweden. We want to further this this part of the science within Sweden or the world, as we know it, and the general causes, of course, for all the medical fields or the raw data lab and stuff, to have successful deployments. I mean, you could take it to save lives is our goal, but anything that's related to this is, of course, quite important for the success of next generation of everything.
That sounds great. And what are you looking forward to with the challenge? Because you will be kind of hands-on involved in what's going on.
Absolutely. Yeah, so we will be from at least a technical point, helping with understanding the infrastructure, moving along stuff. So the actual challenge is a little off our hands, but we'll be helping you with any related infrastructure questions and understanding the how you use the systems. And for us, this is, of course, a great way to network, to meet people, to get out here and then see the new implementations of a existing problem, to also further our understanding of what can be done, what is applicable for this. So yeah, there's a huge opportunity for us to network and find what's the next step for these kind of solutions.
Great. Thank you so much for coming here today. And we really look forward to working with you on hopefully not too much tech support at the time, but great. So thank you so much, CGIT. Thank you, Simon.
Cheers.
So that was the full program, actually, and we will now have a bit of Q&A. So I would like to ask Mina and Benny to come back up just to see if we get any questions specifically for the challenge or the data set. But as I mentioned in the beginning, we also do have a Q&A part on the challenge website where we will update the questions that come in regularly. So you will have the latest information. And we also want to make sure that everybody gets the same information before the challenge. So if we get any questions here today, we will also add them to the website. I'm going to show the timeline as well, so we can just have everybody know what timeframes we have to depend on. But in the meantime, have you any thoughts, something that you forgot to mention before that you would like to bring up now? Or anything that Brian from MIT mentioned that kind of triggered you to how important your own challenge is?
Yeah, I think that was really interesting. I think next step is perhaps when we do the automatic annotation to see how we can the real edge cases with the automatic annotation, how we can improve on that, perhaps having some human in the loop or something like for really edge cases. So maybe some new challenges coming up.
Already thinking of the
really
next.
Really look forward, to see what people come up with this challenge. I think we see that the importance of it, and so look forward to the solution.
Great, thanks. And Benny, any thoughts?
I think great minds think alike, since the point you just raised is the one that I was thinking about. Of course, the human in the loop is important, but we want to focus the task right now on the actual annotation part, and then we can expand it further on.
So we do have a question, and just before I go into the questions, I want to show you the timeline, and you guys here don't see it, and then I see we have a question. Just to walk you through the timeline online. The launch is today, so the application is open, the challenge website is open. As I mentioned, we're closing the applications on January 10th, so make sure that you have your applications in before that. And then we're doing a bit of an assessment of the applications that we received, and we will announce the teams on the 18th of January. And then we have a challenge kickoff 21st of January, and we close for the results to be sent in on February 3rd. And then we have a closing event on the 10th. So either if you are just listening in today because you think this is really interesting, or if you're actually one of the maybe hopefully competing teams, you can still listen in on the 10th of February on the closing event, because we will share some of the information and some of the things that have happened throughout the challenge at that day. So stay tuned for more information about that. And I will read the first question to you, because we actually got 5 questions. So I'll start with at least one of them here. So since the annotation is done when the car is parked, can we assume that the annotation model execution is done offline, not real time?
Yeah, that's
so correct. The annotation latency is not a criteria. Is that correct?
Yeah, that's correct. Yeah.
Quick answer. Very good.
Yeah.
Question number 2. The dataset is made up of images. Is there a combination of sensors, example LiDAR, available in the data?
Yeah, I think you will be amazed by the dataset. I really like it, but it's basically multi-sensor. So you have LiDAR data. It's the range is up to 200 meters. It's very like a dense LiDAR point cloud. So you have a sequence of these LiDAR point clouds, and you have the vehicle bus data, you have high precision GPS. So basically you can use the data set for many applications. And also you have anonymized images in 2 ways. So both faces and license plates are blurred, and also they are deepfake. So basically you can even after the challenge, perhaps check, for instance, how anonymization will affect the performance of learning models and so on. So yeah, and there are more annotation than just object detection, which is the challenge is about. So we have annotations for lane markings, road paintings, for ego road, and also static objects as well. But in this challenge, we are focusing mostly on the dynamic objects and only a subset of them to kind of ease the challenge and make it more easier to start, and also because, for instance, pedestrian and animals, which we will exclude, might not be very common in the data set. So we are focusing only on the vehicles and vulnerable vehicles during the challenge.
Yeah, the data is collected during COVID, so there are fewer pedestrians than normal.
I was going to say, are there fewer animals?
No.
Animals, yes, but pedestrian and still we have good, because we have also collected data in urban scenarios. So still we have good number of pedestrians, but it's really less than the number of cars and vulnerable vehicles. Yeah.
Great. Okay, we have another question. What kind of pre-processing is done on the Sensex data set after collection?
Okay. Yeah. Basically, like we need to check the logs when the logs are collected. So make sure that the quality of data is okay. And also we have done some kind of curation to select, for instance, which frames to annotate and so on. So we don't send everything for annotation, and the data set is basically a subset of that. So basically this processing are done. And also we have done also some conversion of the data. So the format that we log the data is different from what you see basically. But the format that you will see in the data set is much more user-friendly. So you can easily use it. And we will have a development kit as well that we will release it soon on the Sensex GitHub. So by that, basically, you have everything you need to start with the data set. So all the readers, data loaders for different sensors, and reader for annotation, and also the coordinate transformations as well.
So an example is that, for example, with the cameras, we do not provide the raw data from the cameras.
Yeah.
We run it through our ISP to provide it in RGB format that is more useful for the participants. And it's the same with the LiDAR. It's not the raw output, it's processed. So it's a bit more useful or user-friendly rather.
That sounds good. Okay, let's move on to the next question. How and when is the annotated data used? What are the downstream models used after annotation? Example, object detection?
For the challenge, since the focus is on object detection, so yeah, it will be for object detection. As I said, we have different annotations provided for the task. So it can be lane detection, or it can be finding the drivable area for the ego road, for the ego vehicle, and other stuff. You can do static object detection as well, but you can also do other functions in the higher level functions as well with the data set, not just the perception tasks basically. So maybe sensor fusion as well, and also perhaps some planning as well.
All right, great, thanks. And the last question from this person: how and when are the annotation models verified? And I'm guessing that might be after the results are sent in, but we have some logical checks, but also some reviews as well. I don't know, maybe it doesn't make sense if I go into too much details here, but of course, when you send the annotation, send the data for annotation, then when you receive it back, then you basically do some quality checks to make sure that basically it follows the rules and the logic that you want. Okay. Otherwise, you have not good annotations. All right.
But I'm curious, is this question targeted towards our processes or the challenge?
Not sure.
So clarifications might be good.
Yeah, if you want to clarify the question, please do. How and when the annotation models are verified. But we do have some information on the challenge page about how the evaluation will be done. Yes. So please also have a look there. And I also want to highlight that on the challenge page, you can see the both data set descriptions and a more thorough description of the challenge. Yeah. So you will most likely find also a few answers there. And it's produced by you, Mina, and Benny. So all the details are basically in there. We have a question here in the room.
Well, I have many, but I can start with one.
Start with one. And make sure I can repeat it.
Yeah. So I guess this might be about sort of nomenclature in a sense, but what you're describing to me sounds like an offline perception system and not something related to annotation. Why did you call it an annotation challenge when it's offline perception?
Because we want to target the limitations that you have in a vehicle. So if it's completely offline server side, you can do different kinds of clustering and other methods on the entire data set, for example. So one requirement actually that we define in the challenge description is that the solutions has to meet the spirit of the challenge. And what that means is that the solution has to be able to function within a vehicle. If you would say
a low compute solution.
Yes, it's low compute. You do not have access to annotations within that environment. You also only have access to small subset of the actual data set, the entire data set that you're working on. So as I said, you cannot do clustering in that environment. So you have to fulfill all of those requirements that you would have if you would run the software within a vehicle parked.
And I mean, to kind of follow up on that, I guess one thing that I find is a challenge is that there's kind of scope creep in the community around what an annotation is, in that obviously any machine learning model can produce a prediction on an image.
Yeah.
That does not make it ground truth.
No.
It just makes it an opinion.
Yeah.
But that's the same with an annotation,
yes,
to be honest.
Of course, absolutely. I just kind of want to get an insight into the reasoning behind the concept of auto annotations, which it sounds like it would be hard for you to learn more from the data produced by your own algorithms on the edge, right?
Yeah, so I don't know if everybody heard. So the question was about that it's very difficult to learn anything more than what we already have in the vehicles. Is that understood correctly?
I mean, I guess you can use it for data selection, but I would like to understand if you're actually intending to improve your algorithms in the car, or if it's mostly for sending data back to HQ.
The thing is, which I mentioned previously, is since we have to respect GDPR, and that's the real challenge, we cannot send data back. We have to respect those laws. And so we're kind of in a scenario where we have to explore the area. What can we do within the vehicles? We're allowed to send back, for example, model updates and results, but not images, positions, and so on. And compared to what we can do when the car is parked towards driving, we have the opportunity, we can load in much more advanced complex models that we can run. We can do non-causal filtering, we can do sensor fusion. So we have a lot of things we can do when the car is parked to produce a vastly superior output compared to what we can do in real time. Right. And that's what we want to utilize. So, and if that output is significantly better, that can then be used to improve what we have running live.
So maybe the wrap-up question from my side then is that the way I perceive the challenge is that you're asking for a low compute perception system to kind of filter raw data in the car.
It's not really low compute. No. I mean, you have time. If you park the car, go in and sleep or something,
okay,
you have hours to compute a few second long sequence.
Let's reframe it. High latency.
Yeah,
exactly.
High latency perception.
Yeah, and also, you know, for instance, when we run in the car, usually it's not only one algorithm being run. So, and all of them have to fulfill the frame rate that they are supposed to like deliver. Yeah. But here we don't have that challenge either. So we can basically like have an algorithm that creates a very nice annotation, and it takes, for instance, 5 minutes to produce one. It's fine. Hopefully it's not the best solution, but it's fine. I mean, because it's going to be used when the car is parked. So still that can work. Yeah.
All right.
Yeah.
Thank you. And we had a clarification of that previous question. on how and when are annotation models, the annotation models verified, and that was in general,
Yeah.
not specifically for the challenge.
Mhm.
Do you want to
In
answer
general.
that? Yeah.
Okay. Yeah, I think usually like, for instance, I think the annotation company, what they do is, for instance, sometimes when an annotator do the annotations, there are other annotators that kind of randomly go through it, like do some quality checks.
We do have an expert about that.
Yeah, maybe Daniel, you can tell us about that.
I don't want to interfere with the show, but
No, but that would be nice. Yeah.
I mean, the way we think about it is that the difference between a machine learning model prediction and an annotation is that you improve as much as you can until you hit the boundary for human abilities. And there's always a peak level performance for humans with respect to consistency and level of detail, etc. And machine learning models, basically, our goal is to bring their performance as far as we can until we kind of hit the limitations of what humans do. And then it's a cost quality trade-off, how close you want to get and how much money you have.
Yeah.
So for me, auto annotation is nonsense. Like that is like saying, I mean, it means nothing. It means that we think we can learn from stuff we know when we already know it, and we can't. But we can improve efficiency in ground truth production by leveraging existing machine learning models, which to me is a high latency perception system. But now we're getting very specific.
Yeah.
Do we want to
Move on.
We will move
Yeah.
on from there. So we do have another question here. First of all, do you have data from public transport? No, right? This is the data collected by Sensex
Yeah.
and your development vehicles.
Yes.
There
that's true.
may be public transport around it, but
We have
it's not
trams in the
collected
images.
by.
Yeah.
So it's collected by the development cars. Is the annotation from any type of road stakeholder? Do we want a clarification maybe for that question?
Yeah.
Road stakeholder. Would that be like Trafikverket or?
Perhaps. So if you want to clarify the question, that'd be great.
Yeah.
So all of the data is produced by us and our development vehicles. So from that context, you can, I think, figure out.
Yeah, you could be one, of course,
Yeah.
stakeholder and.
But just
Yes.
one thing I can add is that we also provide some metadata information like weather condition associated to each frame that the data was collected. What else? Like things like that. So you can easily like filter out the images more than like the information from the annotation. So that part basically like coming from weather predictions, but yeah, really it's like the data itself is collected by our cars. So,
Okay, yeah, great. And then so it is cars only, data from the cars.
Yeah,
perfect. Great.
and with two development cars. So basically giving you the opportunity to try out if you have trained an algorithm in one car, does it work in the other car with the slight maybe changes or something? Because some models might have struggling with those variations.
Yeah, great. Thanks so much. And for the Raw Data Lab project and the community created there may be other data eventually coming in, but for this challenge, it's the Sensex open data sets.
Yes.
And then we have another question here. If we can annotate object on the edge automatically, why do you need to train a downstream model? Or is the downstream task doing something else?
Yeah, the question is related to what we said in the challenge description. Basically, we wanted to give you an opportunity that you have all the data that you might need available. So we also provide the detections by the 3D objects detection running on a LiDAR data and also on images. So in case, for instance, someone just want to come up with ideas on working on the detections and just go through time, like use the past and future information to improve that, they can also be able to do that. So you don't have to do it to use it if you don't want, but it was just an option, an extra option.
So I will give a few comments. I don't know if it answers the questions, but so the idea is that there are two reasons why we have available annotations from the start. One is to create kind of the seed model, or the model that you kind of bootstrap and improve upon. And the other reason is to have some annotations available so you can learn about how the annotations should look like when improving, and then provide annotations for the frames that we have already the truth for. So the process is kind of, first you start with the seed model, then you have to understand how you can improve it in the edge environment.
Right, great. Thanks.
Yeah.
Nina, anything to add?
No.
Great. So I want to ask, do we have any more questions from the audience here in the room? No? And we can't see any more questions here in the chat either. So we would really now like to encourage you to apply for the challenge and also spread the word about the challenge. And we will also post again the link to the challenge site here in the chat. So that's the last thing you can see. And we will also, as I mentioned, update the Q&A part of the website so you can follow if there are any questions coming in, and we'll do that regularly. So we wish you really good luck with applying for the challenge, and hope that you will come up with some really interesting solutions.
Yeah.
And hopefully we'll see you in January. And I want to say thank you to everybody who participated today. Specific thanks to Sensex. And thank you everybody that listened in online. Please stay in touch. You can find our contact details on AI Sweden's website. And with that, I say have a good evening or a good day. And thank you so much.
Thank you.
Thanks.